Now we have added fill zones, the front copper fill zone and the bottom copper fill zone. You can see here that the PCBs are covered in the copper layer. We have also added few vias over here for connection between the front copper fill zone and bottom copper fill zone. Let's add few vias over here. So let's try this. If I select all these vias and hit Ctrl C, Ctrl V, I can get a copy of all these vias and let's place it over here. So I have vias over this corner and vias above on this corner. This will only help to conduct the current, give an extra conduction path between the top and bottom layer, or it helps to increase the connectivity. Now let's see few of the properties of our fill zone. Highlight or select the front copper fill zone and hit E, and the copper zone properties window pop up. Now let's first of all zoom in so that we can see changes while we are working on it. Now select the front copper fill zone, hit E. Let's take this window a little sideways. Now the first thing you can see over here is the electrical properties and it's the clearance. The clearance is actually the gap between this copper of fill zone and the track. This is the clearance. Currently it is 0.25. So this track or any of the track in this PCB is the gap between the fill zone, copper of fill zone, and the track is 0.25. In order to show you, let me change this to 1 mm and hit OK. Now click on the PCB and hit B to repower the PCB. Now you can see that the gap between the track and the fill zone is now 1 mm. They are 1 mm apart. You can see these changes have been made into the entire PCB, but these changes have been only made into the front copper fill zone. 1 mm, I think it's too much, so let's change it to 0.5 mm, half mm gap between the fill zone copper and the track in the PCB. Hit OK and hit B to repower the copper. Now it's the 0.5 mm gap between the copper of the fill zone and the track. You can see over here. Let me show you in the 3D viewer. Go to view, 3D viewer. You can see over here the gap between the fill zone and the tracks. Now let's see the next property. Select and hit E. Now it's the thermal relief gap. Let's change this to 1 mm to see what happens and hit OK, hit B. Now you have seen that the distance between the pad and the copper layer, the copper fill zone has increased. You can see over here. Let's undo it again and hit copper fill zone, hit E, and now I change it back to 0.5 mm and hit OK and hit B to repower the fill zone. You have seen that the distance have reduced, or the gap between the pad and the copper layer has been reduced, and these changes have been made on the entire PCB. So let's select this again and see other properties. There is another property called the thermal spoke width. Let's see what happens if I do it to 1 mm, hit OK, hit B and re-pour on the PCB. Now you have seen that this connection of the pad with the copper fill zone, its width has increased. Again, let me show you. Select and here open properties. Thermal thermal spoke width, I have done it to 1 mm. So the width of the track that connects the copper fill zone with the pad has increased. So let's do it back to 0.5 mm and hit OK and hit B. Now it's back to which I have selected earlier. So these are the few properties. The other are also like like pad connection. You can choose it as solid, thermal leaf, or leaf for PTH. If you choose solid, click OK and hit B. Now you find that there is no gap between the pad and the copper fill zone, copper of the copper fill zone. But it is recommended to choose the thermal reliefs. It helps to solder and desolder any of the components on the PCB if you have this sort of pattern or this type of connector thermal relief pattern on your PCB. Similarly, as we don't have any track on the bottom side, let's check it over here and let's change the clearance to 0.5 mm. Keep the other setting as it is and hit OK and hit B to re-pour the copper fill. So control save and let's view in 3D viewer. Now in 3D viewer you can see the gap between copper fill zone and the tracks. Similarly, you can see over here. Let me now you can easily see the connection between the copper fill zone and the pad. You can see over here copper fill zone and the pad connection with the help of thermal spokes which we have discussed recently. So let's switch back to component. Now the other thing you can see over here that our copper fill zone is at the edge of the PCB. This is not a good practice that your copper fill zone should reach the edge of PCB, because sometimes if little damage or something hits the side of PCB, this may shorten your this may get short with the copper fill zone. So in order to give a gap between the edge cut layer and the copper fill zone, what we have to do, we will go to board setup. In the board setup there is a design rules. In the design rules, go to constraints, and in the constraints you can also preset any of the constraint like minimum clearance between the tracks, minimum track width, minimum connection width, minimum annular width. These are all the constraints that you can set it. So what we need now is copper to edge clearance. So for our PCB, let me give a 1 mm difference. So first of all, let me zoom in so that we can see what actually is happening. Go to board setup and copper to edge clearance, do it 1 mm and hit OK. And now re-pour by clicking B on the keyboard. Now that's the thing. This is our outer boundary of the PCB and this is our boundary of the copper fill zone. On the top and bottom, this constraint has been applied on both the layers top and bottom, but an issue has arisen that our vias have gone a little out. So let's select these, move them little inside, and after moving that, again hit B to re-pour the copper. Now we have also given gap between the outer boundary and the copper fill zone. Control save and let's view in 3D view. Now you can see our outer boundary is over here and copper fill zone is 1 mm apart from the outer boundary. So there is a gap between the outer boundary. Now our PCB is almost complete for manufacturing. So we have also finalized this, so let's delete these dimensions we have written over here. We no longer need this, and that's it. This is how PCBs are designed in KiCad. In the coming videos we will be using its silk screen, so that I want that we must know where which connector has 5 volt output, which has 3.3 volt output, and we can also add some logo over here. You can write your name over here. We will see in the next video how to do these all things.